Math 102, example 1.1.2, reducing the radical. Now sometimes we get a perfect square, but sometimes we don't. So that doesn't mean we have to just leave it as is or approximate. So let's look at the square root of 98. What are perfect squares that multiply up to that? Our perfect squares are 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. We could keep going. That's usually as far as we'll need to go in this class. So it's only those numbers I care about whether they go into it. So here, you might have to go through a few of them, but 49 will work. 98 is 49 times 2. So let's just rewrite it as 49 times 2. Now, if I have two numbers multiplied underneath a radical, I can write them both underneath the radical individually. I'm not allowed to do that for adding and subtracting, but I can do it for multiplying. You'll notice I put the perfect square first as a clue to me that this is the number I'm going to reduce. The square root of 49 is 7, and the square root of 2 can't be simplified, so that is my final fully reduced answer. Let's look at the square root of 300. Now there's actually lots of perfect squares that go into that. 4 goes into that, and 25 goes into that. I'd like to pick the largest perfect square that goes into it. So the largest would be 100. That is 100 times 3. So once again, let's then rewrite that as root 100 times root 3. So the square root of 100 is 10. I can't simplify the square root of 3, so that is my final answer.